Okay, welcome to today's mini lecture. In today's mini lecture, we're going to look at dilutions. What is a dilution? It's nothing more than taking a known concentration, which is molarity, it's what we've been doing, and we add water to it to make it a little bit weaker. That is called a dilution. We have a formula that we use, which is M1V1 is equal to M2V2. That compares your the molarity, or your concentration before you add the water, to the molarity, or the concentration after you add the water. So let me just go through and just do a couple of problems with you. It says if I added 25 milliliters of 125 milliliter solution of 0.15 molarity of NaOH solution, what will the molarity of the diluted solution be? So in this one, I'm just going to start off and say M1 V1 is equal to M2 V2. So I'm just going to go through. I have the molarity, which is 0.15 molar, and I have 125 milliliters of this. Now I'm looking for M2, which is my second molarity. So it says, well, what would that be if I added 25 milliliters? So guys, just be real careful. Don't say 25 on this side because you added 25 and you already had 125. So that gives you 150 milliliters on this side. So when I solve for my M2, I just simply take the 0.15, multiply it by 125, divide all of that by 150, and I get 0.125 molar as my final answer. So straightforward, real easy. M1 V1 is equal to M2 V2. Now in the next question, example problem, it says how much water would I need to add to make the solution? So what happens is, I'm going to come back over here and do the exact same thing. M1 V1, M2 V2. So this time I have a 1 molar solution. I have 250 here. Then the molarity is 0.5, and it is going to be the volume, V2. So when I do this, V2 is going to be 500 milliliters. That is the volume that I would have to have of my new solution, 500 milliliters. All right, so guys, I do want to work one more, and then I'll go ahead and show you what you need to do, and then we'll start the other side of the worksheet. So it says I have 345 milliliters of 1.5 molar NaCl solution. If I boil it and it evaporates and boils away to 250 milliliters, what will the new molarity be? So in this one, M1 V1 is equal to M2 V2. So in this one, it says 345, and its molarity is 1.5. Kind of did those backwards, sorry about that. I'm looking for M2, and its volume is 250. So my M2 is going to be 345 times 1.5 divided by the 250, which gives me a total of 2.07 molar. So guys, this is just what I call plug and chug problems. You just have to go through, look at what you are given, and then read your problem, substitute into the formula. All right, look at the problems that I want you to work. And it says this is old material. Well, it's not like it's old material. I think we did it yesterday. So on this one, on both of these, we're using the formula. The molarity is equal to the moles of the solute divided by the liters of the solute. So I can do that with either one of those problems. Guys, don't let using a hydrate mess you up. Just treat it as one unit, CuSO4 with 5 waters. Then I want you to do a dilution problem down here. And then I would like to show you another type of problem that we can have that goes right along with this. This is a percent solution. We can do percent solutions two ways. We can either do a percent by mass of the solution, or we can do a percent by volume of the solution. So both of them, percentages are nothing more than part divided by the whole times 100. The difference is if we're using percent by mass, we're using the mass of the solute over the volume of the solution times 100. If it's percent by volume, we use the volume of the solute over the volume of the solution times 100. So when I look at this, it says, what is the concentration in percent by volume of 60 milliliters of methanol in a total of 500 milliliters of solution? So it's going to be the percent of volume to volume is going to be equal to the part, which is the volume of the solution, which is 60 milliliters divided by 500 milliliters times 100. So you just need to make sure that you're keeping up with your units. This couldn't be in milliliters and liters. It has to be in the same thing. So my percent by volume is going to be 60 divided by 500, and then all of that's going to be times 100. So I get a 12% solution. All right. What I would like for you to do is the practice problems that's following. And there's 6 practice problems. A couple of them are your M1V1, some of them are your molarity, and then some of them are your percent of mass or percent by volume solution. All right, I hope that helps you, and I hope that you'll be able to complete the remainder of the problem.